Welcome to Space Connects Us, where we connect space professionals with interesting stories to tell to the wider public. And we're here today to talk about asteroid 2001 FO32. You may already have read about it because on Sunday it will make a close pass to the Earth. Now, close in this sense means at about 5¼ times the distance of the Moon, and that's about 2 million kilometers away. Although there's absolutely no danger of an impact with the asteroid, its proximity does make it a great target for telescopes on Earth. And to discuss this fascinating object and its opportunity with me, and how you at home can log on and watch the close pass, I'm delighted to be joined by Dr. Gianluca Masi of the Virtual Telescope Project. Gianluca is an Italian astrophysicist and an accomplished international science communicator. After receiving his PhD in astronomy in 2006, he launched the Virtual Telescope Project. Through crowdsourcing, he offers real-time observations, so sharing the universe with the world. Gianluca, welcome. I'm so pleased that you could join us here today. How are you?
I'm fine, Stuart, and it is my pleasure to be here with you talking about asteroids, something we really love, and to share all this with our friends around. And doing this with the Asteroid Day people is, for me, honestly, a true and very special opportunity. So thank you very much, and I'm happy to be here with you.
Well, the feeling is absolutely mutual, and we're going to talk a lot about your association with Asteroid Day and the Virtual Telescope Project as we go on. But first, before we go any further, we'd like to thank our global sponsors for their generous support of the Asteroid Foundation and our programs, of which Space Connects Us is one of them. So thank you to the Luxembourg Space Agency, Broadcasting Centre Europe, SES, B612 Foundation, and the Luxembourg Chamber of Commerce. Now, Gianluca, you've had such a long association with us at our sister organisation, the Asteroid Foundation, which organises Asteroid Day on June the 30th every year. Give me that background, because how did you get involved in the first place? Because from my perspective, you've always been there. You're like one of the foundation stones of it.
Well, I must say that the first time I have heard about Asteroid Day, it was just before the very first edition. It was the winter between 2014 and 2015, and I really loved the idea since the very beginning. And I talked with one of the co-founders, Greg Richter's, and I joined the celebration that February, organizing events here in Italy. And for the second edition, 1 year later, I suggested to introduce national coordinators to help Asteroid Day to organize things locally. And it proved to be a good idea. And Asteroid Day is now a great thing, a great family, bringing science, bringing knowledge, and also love for the science and asteroids to everyone around the planet. So beautiful.
Now we've got a picture, or several pictures, in fact, of you from Asteroid Day to show. So these are from some of these are from the live broadcast that we all did from Luxembourg. There's one there I can see from last year where you're in the same room that you are now. Talk us through what's going on here. What are your memories of being involved in the Asteroid Day live presentation?
Oh, wow. Thanks for sharing these images. They really bring to me so beautiful memories. And here I was just talking with great people around the planet doing at that very moment real asteroid observations. It was great because during those hours, during Asteroid Day Live, we have been learning from scientists great things about modern knowledge of asteroids. And here we are also learning what was going on there while they were observing up in the sky. It has been really, really exciting for me. And really, I remember those moments so well. And I am excited right now looking at these old pictures.
Well, I remember being across the studio from you, and I was helping to interview people who were standing right in front of me. And that was all nerve-wracking enough, getting the right people in the right place and me with my right cue card and questions all ready. And I can remember thinking that there were you standing over on the other side of the studio, and you were talking to people on the other side of the world, sometimes through the internet connections. And not only that, but you were also trying to observe asteroids in real time. And I can remember thinking, wow, that you're brave, because you're relying on the weather being good, you're relying on the technology being good. So yeah, more power to you for your bravery at doing that. Well, we're here today to talk about one particular asteroid, and that's 2001 FO32. So first of all, tell us a little bit about why this asteroid is generating so much interest.
Well, first of all, let me say this. Every time an asteroid is around and the people are interested about it, I'm happy, because it is an opportunity for us to reach them with good things from space, good feelings from space, and so on. What is happening here is that this object is coming relatively close. We will say a bit more later. And people are worried by this word, close. But luckily, this is not happening. It is not coming extremely close. It is absolutely safe, this upcoming close approach. But people, every time an asteroid is is approaching, are always worried, and we are trying to do our best to tell that nothing bad is happening. But this is an opportunity, because we can learn about this object. We can improve our general knowledge about asteroids. So this is a gift from our solar system, and we are happy that this is happening now.
Now, one question that seems to be interesting a lot of people seems to be just how far the asteroid away is from us. How close is it? Is it coming? How far does it get away from us? Give us a little flavor about this asteroid's journey through the solar system.
Well, this object is interesting under several point of views, because it is large enough. We believe it is around 1 kilometer large, even if some recent observations suggested it could be 600 meters, so a bit smaller than expected, but still huge, still large. And also, it belongs to the family of the so-called potentially hazardous asteroids. And let me say, Stuart, that this definition is perhaps the reason of concern for the people, because they don't know, likely, that it is a formal definition, just telling us two things. We call potentially hazardous asteroid every asteroid which is larger than 140 meters and able to reach a minimum distance from us shorter than 7.5 millions of kilometers. But it is not, this definition is not saying us that we are waiting for an impact. So this is interesting because its orbit is special for these reasons, and also because its orbit is has a particular shape, quite eccentric, and it is bringing very close to the sun, closer than Mercury, and at the maximum distance is it is beyond Mars orbit. So it is a good traveler. It is having fun around the sun, I must say.
Mm. And we have an image of the orbit here. Let me just find that and pull that up. There we go. There's the orbit. So we can see here that it is really quite an elliptical orbit, quite an eccentric orbit, very far away from circular. And this I find particularly fascinating because perhaps we associate asteroid orbits as being more circular, and yet we think of comet orbits as being much more elliptical in this way. So tell me a little bit about how we get sort of asteroids on these cometary-like orbits where they have these big differences in the distance between the closest approach to the sun and the furthest approach to the sun.
I agree with you because at first glance, really this orbit is amazing because it is so eccentric, and this is something we are used to see with comets actually. And by the way, detailed analysis of this object done by colleagues in this very moment in the right place under the right sky can really reveal perhaps that there could be some connection with a dead comet, for example, something no longer active, but active in the past. And I really like this kind of orbit because I try to imagine to be on that asteroid and how it could be living there. Because as you can see, as we told, we are really living so different conditions, so close to the sun, closer to Mercury, and quite far away beyond the Mars orbit. This is the magic of very eccentric orbits. And I am always fascinated by this shape. I must say that they are less boring than circular orbits, very luckily.
Yes, indeed. And the conditions that the asteroid will endure will be extremely different, much closer to the sun, as you say, in between the orbits of Mercury and the sun, than when it gets much further out beyond Mars there. Now, the asteroid itself is part of a class of asteroids called the Apollos. And I was just wondering, do we know how many Apollos there are, and what's the defining characteristics?
Well, there are a few thousands of them, and when we observe asteroids, first of all, we are attracted by those reaching the proximity of the Earth. You know, there are a lot of asteroids between Mars and Jupiter, for example. They are of great interest, but we are really not worried about them because they are living in a very safe region of the solar system between Mars and Jupiter. But we know a number of objects reaching the inner solar system, but those asteroids able to reach us they could be different. Some of them have a gentle approach. Some of them can even cross the Earth orbit. And this one is an Apollo type, that is an asteroid moving on an orbit, which is able to bring it closer to the sun than the aphelion of the Earth. That is, it is inside the orbit of the Earth. So this is potentially an Earth orbit crosser. This is important because Apollo and the other class, the Athens asteroids, are able to cross the Earth orbit because its orbit is bringing them to the sun inside the Earth orbit. And this is, of course, of great interest also because we have to monitor them with special care, of course.
Yes, indeed. These close passes that these asteroids experience, they give us extremely good opportunities to try to study them with Earth-bound telescopes. Tell us a little bit about the kinds of things that you can discover about asteroids when they come this close to the Earth.
I thank you, Stuart, for this question, because when I was younger, actually a student, there was something attracting me so strong. The possibility that we could understand a lot of things from a point of light. Because the asteroid, if you are not going there with a spacecraft, is for you just a dot of light. And a dot of light is saying nothing to you if you are not investigating carefully. But using the right techniques, you can discover from that dot of light a lot of things, even discovering its shape, for example. And it is strange to believe that you can discover the shape of something looking like a dot. A dot is so poor vision, you know. But if you track the asteroid for a long time, for example, you can see its brightness is changing because the asteroid is spinning like our planet, and its shape can be very elongated. So the amount of light you are receiving back is varying while it is spinning. You can discover that there is a little moon with it. And so it is not alone in its journey around the sun. And all this can be done even with little telescopes. I'm never tired to underline that asteroids offer a huge opportunity also to amateur astronomers to contribute to big science. And studying these kind of things, thanks to the opportunity asteroids like this are offering, is really something precious. And of course, other advanced telescopes can add more details. We can also look at the light we are receiving back just to find for the fingertips of the elements on the asteroid, for example. And we can also use radar observations to refine the shape. So it is a perfect example of cooperation between different scientists, between different techniques, and putting together all this different information, you can really have a clear, detailed, and precious description of the object.
It's one of the things that I find the most fascinating about this subject. And I can remember sort of learning about it for the first time and just being mind blown by this, that just by collecting the light from something very far away, you can know so much about it. And one of the techniques is spectroscopy. And the other mind-blowing thing that for me is that really this technique, it's only just over 150 years ago that technique was discovered and understood, and it's opened up the universe to us as never before. Now we can split the light from all these celestial objects into spectra and look, for the minerals and the chemical elements that are in there. And I think this is one thing that NASA astronomers are planning to do, or doing at the moment, actually, in the run up to this close pass, is to actually observe with the infrared telescope they have on Mauna Kea in Hawaii, to actually look for the mineral content and tell us what kind of asteroid it is. And there are several different kinds of asteroids that we know. We sort of slot them into broad categories, don't we? I wonder if you could run me through those.
Well, we have we know that the composition of asteroids can be different from asteroid to asteroid, and I appreciate what you have said, because spectroscopy is so precious for asteroids as well, because the asteroid is sending back the light of the sun, of course, but adding something, as we said, because of its very special characteristics. We can have stony asteroids, for example. We can have iron-rich, nickel-rich asteroids. We can have also carbon-rich asteroids. And by the way, all this is telling something more, that together with the big science, keep in mind that asteroids are keeping the secrets of the origin of the solar system, they can even be a precious resource for us, thanks to their different compositions, thanks to the minerals and what the things they have on their surface. And so we will see in the future that we will go there mining asteroids. And I find this amazing. To be a young student today is very exciting, because those young people will be involved with these truly exciting new things, new studies. And I would like to go back in time to be here 100 years by now to see what we have about asteroids at that time.
Oh, if I'd step in that time machine with you tomorrow, and because there's so much fascinating things to come, I think. And asteroids, I think, are only going to become more important to our study of the solar system, both for what they can tell us about the origin of the planets and the resources, as you say, that they have, that we may be able to potentially use to further our exploration into the wider solar system. Now, I want to turn for the moment to your virtual telescope project. And I've got another slide here to show of you standing with a very impressive looking telescope. So Gianluca, tell me a little bit about the virtual telescope project. Tell me a little bit about this amazing telescope you're standing next to, and how the whole thing came about.
Oh, well, we were talking about time machines, and with this picture, I am back of 10 years because this one was exactly 10 years ago. And I was so happy and excited to be close to the main telescope, now part of the Virtual Telescope project. The Virtual Telescope project is basically a very simple idea. And all started because I needed something for myself. As an astrophysicist, I had to access my own telescopes every night. But I live in Rome, and from Rome the sky is not good because a lot of light pollution, like every big city. So the telescopes are about 100 kilometers south of Rome. But trust me when I say that even if I was younger, it was very hard for me every night to go there, and at the end of the night to come back in Rome. It was really I was really tired at some point, also because after you have been there for the entire night, driving back is not very safe. So I decided to look into the technological stuff, and slowly, because all this was done with my personal money, I was able to put all this together. And now the telescopes, because we have a couple of telescopes, can be controlled remotely. No one is there. The telescopes are alone. You can connect, you can do everything. And then once I succeeded this, I decided that I could make what the telescopes were seeing available to the people, because the telescopes were at that point connected to the internet, and it was very easy to share on the internet their view. And it has been a revolution for me, because since then I shared the universe with several millions people all around the planet, and bringing the joy of our common universe to the people is, for me, I can express how happy I am to do this every time.
Now, because I'm just totally into technology and gadgets, tell me about the telescope that you've got there. Is that the Cassegrain that's there?
This is a so-called astrograph. It is a dark Kirkham telescope, which is optimized for imaging needs, providing high luminosity, which means speed as in terms of time needed to grab an image, and also a large field of view. And this is perfect because some objects are large in the sky, while asteroids are very small. You can have galaxies or star clusters quite large, and having a large field of view will help you to capture the beauty of the object and the science, of course, of the object. This one is it's a quite powerful telescope because you can really see very dim object, and I fine-tuned both my telescopes to perfectly track even very fast approaching asteroids, because they can track at their very specific apparent motion, and this help to capture even small, and that is faint object, because you really track at their very special motion, and you accumulate their faint signal while they are surfing to the stars. And every time I do this, I'm very happy, because it is like driving a space ship across the skies, you know.
Yes. Now, talking about fast asteroids, that brings us quite neatly back to 2001 FO32, because that asteroid, I believe, is going to fly by so quickly that anyone who's able to see it will actually be able to see it moving relatively to the stars in the background there.
Yes, because this one, as every close approaching asteroids, being close to us is underlining its motion around the sun. Keep in mind that every object in our solar system is orbiting around the king, the sun. But if an object is close to you, that motion is clearly more evident. But in this case, also the special orbit you kindly showed earlier is explaining why it is moving so fast. The relative speed of this object relative to the Earth at the flyby time will be about 34 kilometers per second, which is quite a lot, and its orbit, which is quite inclinated respect to the plane of the Earth orbit and eccentric, and Kepler told us that a very eccentric orbit is asking the asteroid to move faster when it is in the inner portion of the orbit. So combining those elements explain why this object is moving so fast, significantly faster than other close approachers. So this is another reason why I find this object of great interest.
Now, this Sunday, you have an observing event. It's slightly after the actual closest pass because we can't see the closest pass from this part of the world. I wonder if you could just talk me through what's going to happen on Sunday from the point of the asteroid making its close pass to when you'll be able to see it later on in the early hours of Monday morning, in fact. And tell me about the live stream that you're planning so that people can watch along with you at home.
It is my pleasure to tell a bit more because it's for me a true excitement every time, because being a live experience, first of all, you have to face the weather, and in this very moment of the year, being the end of the winter, the beginning of spring in Italy, weather, it is not very reliable. So I don't know what I will find early in the morning when we will go observing. Anyway, should the sky be clear, we will salute the telescope there, and we will ask the telescope to track at the specific apparent motion, as I explained, and we will see this little dot traveling fast across the stars. And at that moment, we will see the object also fading, because as you kindly told, the object will be leaving us at that point, because the flyby will happen a few hours earlier than our live feed. So after the flyby, the geometry between the sun, the object, and the observer will evolve, and the asteroid will show us the shoulders, basically the dark shoulders. So it will be fading pretty fast. And I must say that I was not convinced to organize this live feed, because the object will be very low. It will be fading. It will be early in the morning at dawn, but we love them, and we have to try. We have to try and to share this with other people.
I think if there was ever a motto that applied to astronomers, you just said it there. We have to try. It's out there. It's maybe possible to see it. It's going to be difficult, but we have to try. So
I agree.
you've been observing this object for a little while now, and you've got a great example of just how difficult it is to see this object, even from where you are. You're in Italy, I'm in the UK. From here, it's next to impossible to see it. You've got a little bit further south, so you've got a little bit more of an advantage, so you can just see it. But it's very low on the horizon, isn't it? And I think even you were telling some of the bits of your observatory get in the way of seeing it as well.
Oh, I have to take your words as precious, because you are right. We have to try. We have to try, because looking at the numbers, it is clear that this apparition is not the best one for us. But I say the telescope is mine. I can do what I want with this telescope right now, and let's try. And in the middle of the night, because these past nights, the only opportunity I had to spy this object was basically at local midnight, when it was barely visible south from my location, but it was 15 degrees at the beginning a few days ago. And last night, when we spied, thank you for sharing these images, and it was just 10 degrees above the horizon. I believe that all the professional astronomers there never looked so low, because if you look that low on the horizon, you have a very thick atmosphere, actually affecting the light of your object and basically destroying any potential science in that poor light you are receiving. But what I wanted was to capture this object to document this event, and I was lucky. And last night, in particular, because weather was expected to be bad, but I had my clock the alarm just telling me it was time to try. I opened the observatory and it was clear, and I captured the motion that you are kindly sharing. And I don't know how to explain to our friends, but every time I see such a simple point of light moving in total silence across the sky, I sit and look, and really I can explain, because it is a great emotion every time. Think of this rock surfing the sky and having this opportunity to be close to us and to interact with us, because we are observing, we are trying to study, and then it will move away. This is poetry for me.
Absolutely. It's like finding a secret buried
Right.
in the night sky, a little treasure, something that doesn't announce its presence, that will slip by, with no one to see it and no one to know where it's been. And yet, something about being in the darkness under that starry night and seeing this, natural kind of clockwork of the universe, if you like, just taking place, regardless of whether we observe it or not. This is just what the universe does. You're right. It does give such a deep, strange cocktail of emotions and feelings. It's a beautiful thing to see. And this is a great image, Gianluca. You do yourself down sometimes. This is absolutely fantastic, because you've taken it under extremely difficult conditions, and the difficulty is what you can see on the image as the noise, that's the speckles that are on there. So we have every hope in your and belief in your abilities to capture this on Sunday, shortly, or the early hours of Monday morning, shortly after the close pass. Tell our viewers how they can join in with this, how they can, what time you'll be transmitting from and observing from, and how they can join online.
And we will be sharing this in, a very unpopular time for Europe, because it will be at the end of the night. It will be 4 a.m. Universal Time, Greenwich time. So many people in Europe will be very likely sleeping, while it will be better for our friends in different regions of the planet. And if you want to join this crazy tour, you can just visit our website, www.virtualtelescope.eu, at the time I mentioned, 4 a.m. Greenwich time. And from there, you will find everything you need to join and be part of this amazing journey. Hoping in good weather, but I'm sure that the weather will be with us.
So that'll be 4 a.m. Universal Time or Greenwich Mean Time. So an hour later from Europe, 5 a.m. Central European Time.
Yes, and every time when we organize these events, of course, we have to consider the best moment, because it is the object telling us the date and the time. We can just respect this, and this is another interesting part of the story. You can do, you have no opportunities to change things. That is the flyby, that is the day, that is the time. And sometimes you are lucky because it happens in your ordinary life, early in the evening, for example. But sometimes, like this time, you have to work in a strange time. I think that this is one of the most extreme events I ever organized, I ever planned, because while I love observing, I also love sleeping. So
I think for me, one of the big things about becoming an astronomer was learning that you have no control over this. You know, the universe just does what the universe wants to do, and it's your decision to either be that observer or not be that observer. But you're not in control of it, so you're just there for this kind of like glorious ride, really, whatever the heavens want to show us. Now, I want to roll the clock back a bit more, in fact, and just find out from you, what was it that sparked your initial interest in astronomy?
Oh, I see that you decided to have those old emotions coming back, and they are doing, because I was literally a child with no knowledge in astronomy, no knowledge about the sky, but I received as a gift from my parents a little book telling about the stars, about galaxies, planets, and so on. I could not read at all because I was too young for reading, but images captured my imagination. And later, growing up, I decided to look up, just because I wanted to find where those magic clouds of gas were, because I could not see by naked eye. So in order to find them, I started studying astronomy, telescopes, and it was the beginning of a journey. And since then, I never stopped, and it has been more than 40 years now. And I'm happy, and perhaps even happier than at the time, because, as we said, we are living exciting times, and every day is potentially able to bring a revolution, something very precious, unexpected. And this is another one of the many good sides of this story.
Do you remember what the first thing was that you saw in through a telescope? Was there, maybe it wasn't exactly the first thing you saw, but it was the first thing that truly blew your mind?
The first thing I saw was the moon, because it was easy for me to point with my little hands our natural satellite. And after all, it was also a connection with asteroids, because what I saw on the lunar surface, those wonderful craters, were, after all, the leftover of ancient impacts. And this is I love to look at that experience in this way, because enjoying the craters of the moon, I was, after all, enjoying the authors of those features, asteroids. But my interest in asteroids was significantly later, and because I discovered that asteroids offered the opportunity to discover something. And we are humans, and discovering something is also exciting. And I started looking for them, and I discovered a few of them, and then science of asteroids really was, for me, something I wanted to learn.
So your first view through a telescope was with an instrument of your own. You didn't go to an observatory or be shown through a telescope. You're actually given a telescope and you learnt how to use it, and started to your sort of safari of the universe in that way. What an extraordinary story. Do you have some advice, perhaps, for anyone who's thinking of taking up observing? Should they buy a telescope first? Should it be binoculars first? What would be your advice to someone who's fascinated by this and wants a way in?
I always hope, when I talk to the people, that someone after the talk will start thinking about a telescope, or just looking up, because you can really see a lot of things with your own wonderful eyes. Even if you live in a city, there are bright stars, and they can really attract your curiosity with their different luminosity, their different colors, and they are telling a lot of things already in this very simple way. And I strongly suggest you to start looking around with your own eyes, because the sky will start to be familiar for you. The stars will appear as friends for you at some point, and then you will be ready to go even with a telescope to reach more distant objects, invisible objects, because very likely people buying a telescope without the right training are really disappointed because the telescope is not making miracles. You have, like a car, you must drive it to go somewhere, and the telescope, you have to do the same. So start with your own eyes, share if you want with your friends around, especially when we will be able to do this again. When this pandemic will be over, it will be great to go out there and share the sky in this such a new beautiful renaissance. And at some point, perhaps you will want the telescope, and you will start using it in a great way.
No, it's fascinating to hear you talk in this way about, you know, your love of the night sky, because I really want to ask you about some research work that you did, which links your love of the night sky with Van Gogh's love of the night sky. And we've got an image here of one of his famous paintings, The Starry Night over the Rhone. And you analyzed this picture, I believe, to look for the positions of the stars in there, to say when this painting was actually made. So talk me through that process. I'm fascinated both about how you extracted the information from the image, but more so about what drew you to do this in the first place.
The first time I saw this painting, I was again young. I was at the early stage of my of Italian school, but I was already in love with the stars. And of course, you have the stars here, the Big Dipper. And having a Big Dipper in a masterpiece like this was enough for me to ask something. But years later, because I saw this when I was much younger than the moment, respect to the moment when I did this investigation. But after a number of years, I went back to this painting. I had fresh memories because I really loved it because of Van Gogh and because of the stars. And the question was, is the Big Dipper there because Van Gogh was really observing in real time that group of stars while painting, or it was just an echo in his memory, but without any direct vision? And to answer this, I started another journey using, of course, statistics and science to investigate all this. And at the very end, I could conclude that the position, the relative positions, that is the shape of this feature and its position above the horizon, are absolutely in excellent agreement with the real and the direct experience of Van Gogh under the stars. But also, I had with me the letters he wrote to his brother Theo, where he confessed here his intention to paint the sky, the night sky, while personally under the stars. But there was here a truly unexpected discovery, because after I could show that the stars are there perfectly placed because they were captured live, the direction here is absolutely wrong, I would say, because here, if you consider the terrestrial panorama, you are looking southwest. Southwest is a direction where you will never see the Big Dipper, because the Big Dipper is living in the northern part of the sky. And Van Gogh decided to put together two different things: the southwest portion of his terrestrial panorama with the north direction of the celestial panorama. And this is the magic of art. You can really do whatever you want to put together the things you love. And I find this amazing. And I can imagine Van Gogh doing this in the silence of his night, as you were saying so beautifully, experiencing the stars alone, very likely. And now we are talking about him just facing this masterpiece.
One of the things that I find so fascinating about his work with the paintings that he's done of the night sky is that whilst they're so clearly stylized, they do seem to capture that feeling of being out under the night. I can look at these paintings, this one in particular, and feel I understand what's happening there, and sort of have the echo of that feeling. And I think what's also interesting about it as well is that you mentioned the letters to his brother. And I believe it's in those that Van Gogh talks about how he connects with the night sky, because through various different life events, he's lost all of his religious faith. And yet he still feels a need inside him for something that is more spiritual, shall we say, sort of something more emotional and connected to nature than just the comings and goings of everyday normal human life. And he says to his brother, he finds that link, that serenity under the night sky. So utterly fascinating. Now, we have got some other pictures of the night sky taken by another grandmaster, which is yourself. And I'm wondering if we could have a look at them and you can talk me through these, because, again, they all come from the Virtual Telescope project. Quite a few of them are asteroids, with one surprise that we'll get to. Let's have a look. Which one is this? Is this the surprise? I want to keep that one for later. Well, let's have a look at this one. Look at this. This is a super speedy asteroid, which has quite a story attached to it. So tell me about this asteroid, the day that you took it, and what happened on that day as well.
Wow, that day was a truly busy one. I can say this, and trust me, it is the truth. I was sleeping at the time because it was early in the morning on 15 February 2013 when I received a call on my telephone, and it was an Italian press agency asking for my feedback about an event that happened in Russia, in the city of Chelyabinsk. Of course, I was sleeping, so it was for me something completely new. So I just switched on my computer and started checking around reliable sources. And I was shocked because really something incredible happened above Chelyabinsk. And it was, of course, a meteor which exploded, likely high in the atmosphere, even if a number of people, more than 1,000 people, were injured by the effects of that explosion. But it was really, this made the news, of course, because it was something truly exceptional. But what made things perhaps a bit funny was that we were waiting for the evening of the same day, a record flyby by this little rock, which is now named Duende. At the time, its designation was 2012 DA14. We have been waiting for it since the discovery the year earlier. And it was incredible that while we were waiting for this object, that incredible thing related to asteroids really happened in Russia. And this image is perhaps telling you about my most extreme observing experience, because this object made a record flyby, coming at about 28,000 kilometers above the Earth's surface, significantly closer than many artificial satellites, for example. And I had my telescope ready to track it. It was close and moving pretty fast. It was cloudy, but I asked the telescope to point the object, no matter the clouds, and I started grabbing images. At some point, clouds moved away, and I could capture 10 images, maybe, and here they are. And I was one of the very first on the planet to document with perfectly tracked object this record-setting flyby. And I will never forget, because it was a very busy day since the very early in the morning to late in the night, but very nice experience.
Yes, quite extraordinary. I can remember it vividly as well, because of the events at Chelyabinsk. My phone was ringing very early in the morning as well. I was working quite closely with the Guardian at the time, and we thought the big event that day was going to be this flyby. So prepared articles about that. And then, yes, everything happened with Chelyabinsk. And at first, like you, I thought, I'm not sure this is real. I thought, I sort of went onto YouTube and had a look and just sort of what looked like vapor trails in the sky. And I thought, oh, I don't want to commit myself. And then gradually the evidence, very quickly, really, the evidence just mounted up and mounted up. And it was fascinating as well, I think, because it's quite clear that Chelyabinsk was not a part of this asteroid. It wasn't like a fragment or anything like that. They came from completely different directions in the sky, I think.
You are right, absolutely. And in fact, in the afternoon, after the Chelyabinsk event and before the flyby, many rumors around were telling that there was a connection. But as you have properly underlined, no connections at all, because they really had different directions. And physics is able to tell us when two things are parents or not. And in this case, it was just a coincidence, an incredible one, but still a coincidence. But I was happy again, because I'm sorry, of course, for all the damages, but at least we could learn from real facts that we really had to take care of asteroids. Absolutely, absolutely.
Yes, indeed. Now we've got another one to show here. It's this one. So superficially, this one looks like another really fast-moving asteroid. But that's not the whole. That's not the whole story here. So talk us through this, because this is fascinating.
This is really another unexpected surprise, a gift, as I say, because in November last year, this one was discovered, and it looked at the very beginning, at the very hours, like a typical near-Earth asteroids. But soon after, people at Jet Propulsion Laboratory started suspecting that it was connected with an old lunar mission, the Surveyor II. So, and it turned out that this one really is a space debris from that mission. But what I really want to share with you here is the funny behavior of this dot of light. On the left, you see a trail with dots, okay? But you now understand why, because on the animation on the right, you see the object is blinking. And of course, this is happening because it is a very elongated body, which is spinning pretty fast. And for people loving some technicalities, you can see on the bottom the so-called light curve, which is a translation in a plot of the aesthetic experience you have from the images. And yes, it was confirmed to be connected with the Surveyor II. And another funny thing is that this object has been a temporary minimum for us from November last year to basically these days. And now it is leaving for its journey around the sun.
Yeah, this is super interesting. That this piece of old rocket and Surveyor II was launched on September the 20th, 1966, and it's been in space just as a floating piece of space junk. If my space history is correct, I think Surveyor II didn't work correctly. I think it failed en route, and it arrives back at in the Earth's vicinity, and then gets captured by the Earth's gravity, so that for a number of months it's like a mini moon to our planet, and then it drifts back out of the Earth's gravitational grip again back into space. Correct me if I'm wrong, Gianluca, but have we seen tiny asteroids doing this kind of thing as well, being captured temporarily by the Earth's gravity?
Yes, this happened to my knowledge a few times in the past, and this is telling how intriguing is life in the inner solar system. And there are many things in action. Dynamics in the inner solar system is such a wonderful world. And even this case, together with the temporary capture, is intriguing because it is a brilliant demonstration of, the cooperation between different scientists. Because first of all, these objects have to be discovered, and we have special telescopes surfing the skies all the night, every night, to look for them. Then you have other people taking taking images to extract precise positions of the asteroid to calculate the orbit. And then you have other people doing a very careful job just looking at the orbit and to understand how the orbit look like. And from here, they could connect with the Surveyor II mission. And even if that orbit will be of interest for our planet for a potential impact in the future. So I find this case so beautifully explaining about all the people involved in the asteroid discovery process, from the discovery to orbit determination, orbit evaluation, and at the very end, object characterization, because to understand it really was a space debris, astronomers had to take images, doing spectroscopy and understanding that what they were seeing were not from a natural object.
Yes, beautifully explained, and quite clearly shows how each step in that process is absolutely vital. Now, I'll tell you what my little dream is for these mini moons, these temporarily captured asteroids, and that's that one day we have some sort of spacecraft that's ready to go, or perhaps it's in orbit already, and that when we detect one of these mini asteroids that's become a temporary moon, we can get that spacecraft to that object and land on it, maybe even capture it, bring it back to Earth or something, and have a good look at it right close up. Well, time is nearly upon us, I'm afraid, Gianluca. But for anyone who's joining a little bit late in the stream, I just want to underline again that they can join you in the early hours of Monday morning. So that's Sunday night going into Monday morning. This week at 4 a.m. Universal Time or Greenwich Mean Time, 5 a.m. Central European Time, and you will be streaming images of Asteroid 2001 FO32 live as you see them from your observatory. And the URL to use is www.virtualtelescope.eu. So, as always, Gianluca, I wish you clear skies. Particularly, I wish you clear skies this weekend. And I want to thank you so much for bringing your enthusiasm and your expertise once again to share with all the people who are watching. So thank you very much indeed, Gianluca.
Thank you so much, Stuart. It has been for me a real privilege to have this discussion with you and to reach our friends out there. And we will be looking up next Monday, and we will let you know about our observations. Thank you very much.
We totally look forward to hearing about it. So with that brings our edition of Space Connects Us to an end. Thank you so much for joining us this afternoon and for watching. We wouldn't be here without you. And we also wouldn't be here without the generous sponsorship. And so a big thank you to the Luxembourg Space Agency, Broadcasting Centre Europe, SES, the B612 Foundation, and the Luxembourg Chamber of Commerce. From all of us here at Space Connects Us, clear skies and have a good weekend. Goodbye.